Good morning, everybody. Imagine you have a suspension, yeah? And you have to filter this suspension. We are talking about cake forming filtration. Then the cake you have to wash to deliver what is requested a definite performance, yeah? That means I want to filter a definite amount of suspension in a definite time. I want to have a definite moisture content and a definite washout content of the discharge cake, the purity of the discharge cake. The question is that first, if we have this suspension, if not a similar suspension is running somewhere, the first question is that what kind of apparatus we need? Yeah, this is the proper apparatus selection. And after we have decided what kind of apparatus will be the optimal one, then we have to be able to design this selected apparatus. That means, for example, what area, what filter area in it. It is not enough. Depending on the settings, the design, I am talking about optimal design. That means for definite settings, for the same requested performance, we may need the minimal filter area. And and for that, of course, the first what is necessary is to characterize the suspension and also the cake structure characterizing parameters. This is very important. In any way, as I told yesterday, when we have to characterize the performance of a definite filter apparatus, we have to talk about efficiency parameters and kinetic parameters for washing and delivery. Only by quantifying the kinetic parameters and the efficiency parameters, we can be able to judge the performance, to quantify the performance, to have first reliable design. For that, of course, we need some tools, yeah? And as we know, when the suspension is not known, not any test data before, then we have to go to the laboratory, for example, a laboratory pressure nudge, do some tests, and see how the filtration, washing, and delivering behaves. How it behaves. We have to quantify the behavior. How we quantify the behavior. This is what I am telling efficiency parameters. These efficiency parameters make this suspension unique. And when I'm telling about suspension, I'm talking also about cake, filter cake. So that is very important. Let's see a project description. We have a given suspension, a membrane filter press unit has to be designed. As I told you, first of all, we have to decide if the membrane filter press has to be used. But let's see later, after having tested this suspension and after we have defined the efficiency parameters, only then we can talk about membrane filter press. And these are the three main result parameters. Solid throughput, kilo per hour, dry solids, the moisture content of the discharge cake, and the washout content in gram impurity, for example, per kilogram dry solids. That is a typical unit. What are the main questions? What is the needed filter area? And the number of needed filter elements, which is the optimal plate height? That is optimization. Here you can have a plate height of 20, of 10, and so on. And this is also an important optimization task, and which is the needed cycle time. So for that we need, of course, equations. Yeah, that means to calculate these result parameters. The first result parameter is the solids throughput, kilo trisolids per hour, and then based on this equation, that is the area proportional, of course, to the area, and here you see the KK and the time components, formation, washing, squeezing. We are talking about membrane filter press, delivery, and the technical time. So, and here we see this depends on the filtration time, washing time, delivering time. The delivering time depends on the moisture content. If I want a very low moisture content, I need a high delivering time. High delivering time means low solid throughput. That means at the end is we have to do a compromise. The same is the washing. If you want to use a high wash liquid amount, that is the specific parameter here, then you need high washing time. That means again low solid throughput. Yeah? So you see, that is what I told you before. We have cake formation, cake washing, cake squeezing, cake delivering. These are here the important, that is the specific solid throughput. And you see here, these are the efficiency parameters I told before. Porosity of the filtered cake. That is very important. Permeability for delta P1 bar. Compressibility of the cake going from 0 to 1. 0 is incompressible. If, for example, I know that the compressibility is 0 for water membrane filter press. An example. Yeah? So, that is the specific filter medium resistance in millimeter. If I say the HC value is 5 millimeters, that means the resistance of the filter medium is equal to the resistance of 5 millimeter filter cake. Yeah, that is very important parameter also, and that is the kinetic parameter. That is a kinetic parameters means dimensionless time, dimensionless filtration time, dimensionless washing time here. That is the kinetic parameter for the washing. And you see here, the washout content after washing depends on the kinetic parameter and the efficiency parameters, always. The same is here with cake squeezing. We assume an equilibrium, yes, and in this case, you see important efficiency parameters, that is the ENM, that tell us how is the moisture content of the squeezed cake depending on the squeezing pressure, on the membrane pressure. That is this efficiency. The higher ANM, the less the moisture content for a given pressure, squeezing pressure. If we deliver the cake after squeezing by gas pressure difference, then of course we have to know the cake permeability of the squeezed cake. And that is here, this APC, that is, let's say, how the cake permeability is reduced with the pressure. Yeah? So in cake delivering, similar. We have here the efficiency parameter for the delivering and the kinetic parameter. The kinetic parameter, again, it measures the time. Please note that these efficiency parameters for cake formation are not only influencing the cake formation, but also the other steps, washing, delivering. Why? Because these parameters are in the equation for calculating the kinetic parameter. It's understood, you see that. So you see now, if we want to characterize the suspension for cake formation, washing, squeezing, delivering, we need, besides the suspension characterizing parameters, viscosities, densities, solids mass fraction, we need also these efficiency parameters. And these we can get only by doing tests. So lab test, pilot test, and so on. And also, when we have a definite apparatus, we can analyze the data of an industrial apparatus. But that is a new application. So here is an example of 4 tests with different pressure difference, cake formation pressure difference, why different pressures to get the compressibility of the cake. Definite amount of suspension, that is the cake height form with this suspension. Then we measure the filtration time, definite pressure difference for washing, definite wash liquid amount. Then we measure the washing time, definite squeezing pressure after washing, yes. And then we make a flow-through test to get the permeability of the squeeze cake, definite amount of liquid, yeah, that is in this case wash liquid, definite pressure difference from the flow-through test, and then that is the time needed so that this given liquid amount above the cake goes through the cake. And then 4 bar pressure difference for the liquoring, 600 seconds for the liquoring time, and then you see we can measure the gas flow rate. At the end of these 600 seconds, the liquoring time to design the compressor, and then that is the final cake height after squeezing, after the liquoring at the end of the test. And here is the mass of the wet cake, the mass of the dry cake, and then the washout content. So this, as I told you, that is now 22 years I have developing this program. That is the FILOS software. The motivation was the following. When we had in my 3 years after the university as responsible for solid liquid separation and crystallization, we had new project, and we are always too expensive because we didn't have this methodic how to minimize the needed test, yeah, and how to easily, with just small lab scale test, to be able to have a proper selection of the apparatus. And then that was the motivation 23 years before. And you can see here, what you see is very important. All the blocks here is for the analysis of test data, and then you can see analysis of cake formation test data, cake squeezing, cake washing, cake delivery. And here this block is for design or simulation of the performance of all important filter apparatuses in continuous and batch filters. Let's go to this project here, and you can see this is a module where you can enter all your measurements for all steps. In one table, you have this. And not only that, you have this yellow background color. These are efficiencies, porosity for formation, permeability for formation, washing kinetic parameter, porosity for the liquoring, kinetic parameter for the liquoring, efficiency for the liquoring, efficiency regarding the gas consumption here, and also efficiency for washing. So with this table, you can immediately judge your test, the quality also of your test. At the end, you have all data here in this main protocol window. In just one click, you go to these different modules here, and you can see the results in form of diagrams. For example, in squeezing here, you see calculate squeezing parameters, and you see these efficiency parameters. I told you, A and M, that tell us how the squeezing pressure influences the moisture content. Yeah? You see also the efficiency for the permeability, how is the reduction of the permeability with the high pressure, the squeezing pressure. Is an example. We have such curves, theory-based curves, which are very important to judge the quality of the test, and at the end our purpose is to get reliable efficiency parameters. Otherwise, any calculation, any simulation is just a game. All right? Let's go now, you see here, you can go in the program to any window. Let's go to these filter presses. That is the issue. What we wanted here. That is the results, the efficiency results for this suspension, related also for all steps, formation, washing, squeezing, delivery. And you see, by having these efficiency parameters, and the most important are the permeability PC0 related to delta P1 bar and the compressibility. Why? I explain you that these two very important parameters influence not only the cake formation, but all other following steps. So, based on these two parameters, we have the so-called suspension typology. What means that? You see here, cake permeability very low, very high. So we have some drawers, some groups, yeah? And here that is the compressibility. Very low, very high permeability usually is connected with very low compressibility, and very low permeability connected with very high compressibility. So in our case, we know that that is here, these groups of suspensions. And here you see in this area, these are typical filter presses and filter press automats. So you see an example now. I don't need any pilot test to decide if this suspension is for membrane filter press or for a drum filter or for a pusher centrifuge and so on. So that is very important because with that, again, we are able to do, I'm sorry for that. Okay. You understand what I mean? That means for our suspension, that is membrane filter press. That is the result. Let's go back to the program. And you see here, what we have is a definite design. We want two, that is this design. We have a membrane filter press that is 2 bar maximal pressure with a centrifugal pump, and we want to do a rest filtration by using the membrane pressure. We do this in some cases, yeah? Not necessary, but we can do this. And then we wash with 2 bar. Then we have assume a technical time of 30 minutes. Is the time component not belonging to formation, washing, squeezing, delivery of the cycle time. And so that is, we assume we squeeze the cake after washing with 8 bar. Now you see the program calculates, you see these min and max values. That means what is possible. And this is, let's say, we assume now 20 millimeters thickness of the plate, yeah? That is the thickness of the plate. That is an average. If we use a membrane filter, average thickness for the membrane and the plate. This is what, and then automatically the program calculates the filtration time and many other parameters. You can enter any of these, but that is a default input. So we want to have a good washing, and that is the kinetic parameter. That is the important 3. 3 times the voids of the volume of the cake we use as wash liquid. Yeah? Program here calculates then that is the squeezing pressure, and then the requested performance 25% moisture content. To have this, the program calculates automatically the kinetic parameter, the delivery kinetic parameter. But this can be done only if we have all these material parameters and actually the efficiency parameters. You see them here. Due to the time problem, let's believe me, this what we determine using the protocol, the analysis, the program takes them automatically in the simulation modules. So these are the material parameters, otherwise we cannot do any calculation. And you see here, what we want 20 tones in 12 hours, yeah, to filter. That is here. And so based on that, that is the calculated area. We need 106.3 square meter filter area, and then that is the specific time components. As you can see, the smallest is the filtration time, yeah, the specific filtration time. Then when you do here, after exiting here, you have here choose filter from database. So, and you have here, let's say the format 1000 millimeter, and then the number of plates here give us, in this case, that is this one, for 20 millimeters, give us here the area. So that is approximately what we calculated in this design module from that. Now the question is that this 20 millimeters thickness the optimal one? We have the possibility to determine the optimal thickness of the filter press, and that is, as you can see, around 12 millimeters, not 20. So let's go to the optimization by doing a design with the 12 millimeters, so the others are the same. That is the design module, as you see, for 12 millimeters. And you see the area here is not 119, is 71.8. That means for the same performance, you need much less area. Yeah, that is important. So we have in this case the optimal performance, so we guarantee a definite solid throughput, this moisture content, and as you see, the program has a high flexibility regarding the inputs here. You can input any of these parameters, and you have always a guide by having the mean max possible. Let me just imagine now, you go and design a drum filter with the same requested performance. Due to the very low permeability, in this case the drum filter is not a proper one. You see, of course, you need much less area. Yeah, that is the design of a drum filter. Here, 15 millimeter cake height, rotational speed 0.2 per minute, because more we can have also 0.3 based on our restrictions here, and that is what we want, 20 tones in 12 hours. The same performance. And what happens here? Okay, we can reach the solid throughput, no problem. See the moisture content here. Where is that? Here is not 25 or 30, was that? Is much higher. Why? In this case, the kinetic parameter, the efficiency parameter is the same. The kinetic parameter is too small. That means, even as you can see, no gas throughput here. That means the cake in this case is delivered 77% saturation, but still the gas hasn't yet reached the filter medium. You understand what I mean? So that is the way, concluding now. You have a that means you have a tool. I didn't have a little more time. But the way is that you can do really a simulation in 2-3 minutes. And you can vary any parameter you want. That is, I always respect the knowledge of the people in the praxis. But believe me, that is my experience 35 years now. These are things you cannot do. You cannot predict if you don't have such calculation tools and such programs which make it more user-friendly. You cannot say what is the optimal cake height. You cannot know fluctuations of changing of any other settings parameters, what is going to be the result. And we don't want to go every time to the test, to the laboratory, or to do pilot tests for predicting, extrapolating, interpolating of the performance of the filter apparatus. Thanks for your attention and your questions.